So in Nexus, we have various platforms. The popular one today is 9000. But few years before, 7000 and 5000 was popular. Because of 9000, they now don't speak much about 5000. 3000 just came like this, from somewhere. 3000 was there from the beginning, but it was not popular. They removed 5000 when 9000 was introduced from the agenda. It doesn't mean that 5000 is not in the market. It's still in sales. A very widely sold series, 5000. And now we also have 3000 gaining popular. And 2000 is there from the beginning. We will see the differences between these things later. Implementing Nexus platform, various designs, where 7000 will fit, where 9000 will fit, 2000, all those. Managing platform, you can manage using CLI as well as using DCNM tool. There are also other front-end tools available for management. We know about port channel. We learned this in enterprises, service provider tracks. Port channel is aggregation of link between two switches. But if you would like to aggregate link between three switches, we call it as VPC. This is supported in Nexus. VPC is a layer 2 technology. You know about this one very well, but we learn again here. First hop redundancy protocol. But when we talk about Nexus, only VRRP is supported. No HSR. Securing the device, features like SSH, Telnet, encryption, etc., AAA, all those things we'll see here. Nexus devices, they do routing. They also do switching, routing and forwarding. You can enable BGP, you can enable OSPF, EIGRP, all routing protocols, STP, MST, all. VXLAN is another important topic. We'll learn this one along with EVPN. VXLAN along with EVPN. For that, BGP knowledge is needed. We are all having BGP knowledge, so we can easily do EVPN along with VXLAN. Quality of service, marking, prioritizing, etc. can be done as we used to do in routing and service provider track. You can also do here in Nexus. Programmability, if you are aware of this Python and all, you can also leverage those things here. Very important is this one. See, programmability, you have to manage by yourself. I came to networking because I hate programming. 20 years back. I was in a Masters of Computer Science. Though I scored very good mark in Java. Those days Java was the protocol, the program, C++. Though I scored very well, but I did not like programming. The reason is after writing 10 pages sometime of code, you get one small windows popping up. I'm not satisfied with the work and output. Windows programming using jar, Java based. I did not like that. So I came to networking. So I don't want to go back again. If you are aware of this program and all, you can also do such programming thing for automation in NEXUS. Nexus operating system. That's the operating system that runs on Cisco Nexus device, NXOS. Very important thing is this storage part. This will be totally new for you. Cisco Nexus is not providing any hard disk or array of disk. This is not going to give you a storage learning. For that you have NetApps, IBM. Then what are we talking about in network storage? We are not talking about network storage. Sorry, we are talking about Nexus storage services. Storage services. What does it mean? Access list is a service, layer 3 access list, standard and extended access list, is a service in IPv4. Likewise, you have storage services like based on the WWN. What is WWN? Those are the identification to identify a location of the storage. Like we used to have IP address to identify a computer. To identify a disk, to identify a storage box, there is an address called WWN, worldwide name, WWN. So this is not simple switcher router. Nexus is not just a Ethernet device. This is also a storage device, SAN device, storage network area device. It's not only a LAN device, local area network, it is also a SAN, storage area network device. So SAN services is what here it means. You see the next line, device analysis and zones. Meaning, if you are not comfortable in handling that 64-bit WWN address. See, WWN address size is 64-bit. Some vendor even uses up to 128-bit. As per the standard, the storage address can be between 64 to 128. So if you're not comfortable using that WWN address, you can give a name to each address, like a domain name. See, we never use IP address to reach Yahoo. We simply say www.yahoo.com, isn't it? We simply say www.yahoo.com. Yeah, so This yahoo.com is a alias of some IP address. Instead of calling by using IP address, you call by a name, which is also supported in NEXUS. Do you understand this one? If you want to locate a disk, we usually use WWN address. Instead, you can give a name for the address called alias, and you can start using alias. When you use alias, the corresponding address, WWN address, will be used. Do you understand this alias? And zoning is like an access list in a storage service. Zoning is like access list in storage service. You know what is access list? Permitting. Who can talk to whom? Likewise, zoning can say Girish computer can use that particular disk in the big storage array. Mithun computer can use this disk from the big pool of storage. That mapping between your PC and the remote storage. Where is the storage? It's not local hard disk in your laptop. It's a remote storage somewhere where the entire office, all employees, put the data and retrieve the data. Now, for each employee, zoning is done. Otherwise, what will happen? When Midhun writes, if zoning is not done, there are chances when Midhun writes something, it will go and overwrite Girish data. So, the allocation, the partition has got a WWN address. Mithun's laptop has got a WWN address. When you have an FC card in your laptop, then you will have a WWN address. What is FC card? Fiber channel card. That mapping with Midhun's FC card WWN address and that storage which is partitioned for Midhun WWN address, mapping them so that they can talk is what called as zoning. So if you don't do zoning, not possible to go and read from a disk, not possible to write into the disk. Zoning is like an access list, but the addresses are not IP address or MAC address. The addresses are WWN, worldwide name. Also, we will discuss about fiber channel over Ethernet, FCOE. And then we will also discuss about node port virtualization, NPV, node port ID virtualization, NPIV. Very interesting stuff, NPV, NPIV. Right? All these are there. As an optional topic, I'm adding one more to this, which is OTV. Not listed here. It was very famous because they mentioned that 7,000. I would like to also teach OTV along with this topic. Why OTV is removed from the list? Why OTV is not in the objective? Because of VXLAN. VXLAN is an advanced level of OTV. Because we are learning VXLAN, they removed OTV. But I would like to start with OTV only. Then we will go to VXLAN. So I'm adding one topic to this Cisco's objective, OTV, which is a very interesting one. So I would like to start with a topic which is not in this list. Now, what is OTV? Overlay Transport Virtualization. It is supported in NEXUS 7000 only. What about 9000? No, not supported. All right. So it's only supported in 7000. This feature is available only in NEXUS 7000. Overlay Transport Virtualization. OTV is nothing but layer 2 extension, layer 2 switching extension. So it's layer 2 routing. That is why it is called as MAC routing. Now, I also said another word, layer 2 extension. You can also call it as LAN extension. We have seen this type of layer 2 extension in MPLS. You remember VPLS or XConnect. This is something advanced than that. VXLAN is much more advanced than this OTV. Anyway, what is OTV? It is layer 2 routing. What? How can layer 2 routing? Layer 2 is usually switching. Layer 2 usually uses the data plane. But here, layer 2, which is MAC address, using routing protocol, using control plane. Understand? MAC routing means what? Layer 2 using the control plane for what? For distribution of MAC address and for reachability. Yeah? Distribution of MAC address and for reachability. Usually the IP addresses are IP address and subnet masks and subnets, networks, metrics only get distributed through this control plane, through this routing protocols. Usually routing protocol distributes what? Network, how many hops, network, composite value, network, cost, network, attributes. That is how the control plane provides the reachability in layer 3. But here there is a control plane providing reachability in layer 2 level. Like here we are seeing MAC reachability between different LAN. If you see a picture, you will understand this. So let me take you to the picture, then I'll bring you back. See this picture here. There is a big internet cloud. No, not this picture. I'm looking for a better picture. See this one. South, west, east. You have a very big internet cloud in the middle. These three may be in three different ends of the world. Yes, this can be in Colombo, Sri Lanka. This can be in Perth, Australia. This may be in Dallas, America. Now, the LAN of West, East, and South is extended. VLANs of West is extended to the East and South. VLANs, layer 2. In another word, this routing in the middle is not at all considered when the packet moves from west to east and west to south. The routing is not considered. As two computers in a same local area network communicates, the computer in the west and south also communicates. They communicate as if they are within a room. It is because the LAN has been extended. VLANs are extended. MAC routing is done, not IP routing. IP routing is there in the cloud, but that is not considered. You see, from here to here, there is routing. But you also see a tunnel. That is what called as OTV tunnel. OTV is control plane. Underlay is normal routing. Overlay is OTV control plane, OTV tunnel. Logically, it is like three NEXUS switches connected using a LAN switch. That's how the tunnel makes the stop here. So here VLAN 10, here VLAN 10, VLAN 10, they're all extended. If you have multiple VLANs, then this LAN acts as a trunk. This tunnel will act as a trunk. But this is not real LAN switch. This is a very big internet connecting Australia to Colombo to Dallas. So this is an underlay overlay technology. Underlay is normal IP routing. Overlay is MAC routing. Overlay is provided with the help of this technology called OTV. Overlay, that's why it is OTV. Overlay, transport, virtualization. OTV control plane. Overlay control plane. Now, so OTV is MAC routing. I hope you understood this particular point, MAC routing, which means the control plane protocol is used to exchange the MAC address reachability information between the devices providing LAN extension functionality. This is a significant shift from layer 2 switching from the traditionally leveraging data plane. It is justified, which is justified, I need to flatter. Now, layer 2 communication between the sites resemble routing more than switching. As I said earlier, OTV is an overlay. Over this overlay tunnel, the MAC address gets distributed from north to south to west to east using control plane, using a routing protocol. Using a routing protocol, you're going to distribute MAC address. Usually routing protocols distribute what? Network, layer 3. But here, because the MAC address is distributed and using that MAC address that you have learned through control plane distribution, the layer 2 communication itself is resembling like a routing. It's more than switching. Now, in OTV, if the destination MAC address is unknown, will not be flooded. That's the difference between normal switching and layer 2 OTV switching. What is the difference between OTV switching and normal switching? Normally, when a packet arrives to the switch, if the destination of the packet, if the destination MAC address of the packet is unknown to the switch what it does? Flood. In OTV, those flooding will not happen because it is not necessary also. You will come to know why it is not necessary a bit later. I am going to explain after a few minutes. So one thing, this is very important to know, maybe in interviews, they may test you in this. What if the destination MAC address is not known to an OTV device? It will drop. Now here there is one reason given. Because it is going to drop, we prevent waste of precious bandwidth across the WAN. Yes. See, WAN, you pay money for WAN connectivity between Australia to Sri Lanka and from Sri Lanka to Dallas. You pay money. So you cannot simply flood and waste the bandwidth. So OTV won't flood. This is one of the advantage. But you know the truth, if the destination MAC address is unknown to a OTV device, it means the destination is no more. If the destination is truly present in somewhere, then every OTV device will know the destination. If the destination is not there in the OTV device, which means that destination doesn't exist. So it is good that it drops. It is good that it drops. See, earlier it was there. The destination was there. But now it is no more. OTV devices are immediately updated. So when a packet goes to OTV device with the destination MAC address, and if the destination MAC address exists, then packets are forwarded. If not, the destination doesn't exist. So it has to drop. It is dropping. It is good that it drops because the destination doesn't exist. If it will flood, then it would have been a waste of the precious bandwidth across the WAN. OTV also introduces the concept of dynamic encapsulation for layer 2 flows that needs to send to the remote location. This is the secret. How OTV can extend layer 2? By encapsulating. Yes, it encapsulates with layer 3 so that it can go to the remote layer 3 and deliver the packet. There it gets decapsulated and it gets delivered to the appropriate VLAN. That is what explained in the following 3 lines. Each Ethernet frame is individually encapsulated into a IP packet. Why? Because with only IP, you can route from Ceylon to Australia. So inside it is layer 2, but on top it is OTV encapsulation with IP. The packets get delivered from Sri Lanka to Perth in Australia. There it gets decapsulated and it can find the original layer 2 header where you see the VLAN marking to which the packet need to be delivered. And the packet is delivered to that VLAN in the remote site. That's how the layer 2 extension is happening. So you no need to go for MPLS now. With MPLS we used to create what? VC, virtual circuits. Pseudo wire we used to create. You remember? VPLS, VPWS. So here you don't need MPLS, you don't need XConnect, you don't need VPWS or VPLS, you don't need MPLS encapsulation. Without all those services, you can achieve the same layer 2 extension. The immediate advantage includes improved flexibility when adding or removing sites to the overlay, more optimal bandwidth utilization across the WAN, and independence of transport characteristics, meaning there is no limit. You have 3 sites: Perth, Colombo, Dallas. If you want to add Tanzania, you can easily add. New sites can be easily added. You want to add another one, Oman, you can add the site also. Over the WAN, the bandwidth also utilized in a very optimal way. But for that, multicast support need to be there in the ISP side. We'll talk about that in detail in a few minutes. Now here, independent of layer 2, layer 3, layer 1 technology, independent of layer 1, layer 2, layer 3 technology, this OTV can work on top. Yep. Finally, OTV provides a native built-in multi-homing capability. That's what we just spoke. Sorry, this is not the one. Here we spoke, you can have many sites. You can add site, you can remove site. It's very flexible. Not only that, you can have multi-homing capability, meaning you can have more than one OTV edge device in each site. You see in this site, how many edge device you see? On the west side, there is only one OTV edge device. For redundancy, I can have another one also. Another Nexus 7000 series. This is Nexus 7001. This is Nexus 7002. This is for high availability. If this fails, this is there. This is called multi-homing scenario. Finally, the OTV provides native built-in multi-homing capability with automatic detection, critical to increase high availability, high availability of overlay solution. So this is very important, very good, very important for overlay technologies. If the edge device goes, still you have the other edge device to provide high availability, to provide that layer 2 extension continues. So you can have two or more devices can be leveraged in each data center to provide LAN extension functionality without running the risk of creating end-to-end loop that would jeopardize the overall stability of the design. So even though you have two devices, this won't cause loop. This is native multi-homing. This will not cause loop. So this is achieved by leveraging the same control plane protocol, but that's the secret. This is not using spanning tree. This is not using spanning tree. If you use spanning tree to prevent loop, you see you got two nexus. What if loop occurs like this? To prevent this, a layer 3 control plane protocol is used. You know what the protocol is? ISIS. We'll talk about this later. So what I'm trying to say here is there's going to be high availability with no loop. And it is achieved by using the control plane protocol for MAC address exchange information. And these control plane informations are exchanged over the overlay or inside the tunnel. See, the MAC address of this site is advertised through the tunnel to this site and this site, so that they will learn the MAC addresses of the other sites. They all learn the MAC addresses of other sites. That's why we say this as layer 2 routing, layer 2 control plane, layer 2 routing. MAC address informations are distributed, same like IP address information usually gets distributed over the routing protocol. So there is no need to extend any STP over the tunnel. It's only the layer 3 control plane protocol that is going to distribute the MAC address information, at the same time avoids loop whenever we have multi-homing scenario. Is this so far good? Did you understand? What you should know by this time is OTV is an overlay tunnel established between the sites, and this tunnel is capable of distributing the MAC information between the sites using a control plane, not the data plane, using the control plane protocol like ISIS. So for ISIS is not mentioned anywhere in this page, but later pages we'll talk about it, maybe page number 7. So you no need to worry about loop because you got a layer 3 control plane to take care of the loop whenever you have multi-home capability, multi-home scenario. What is multi-home scenario? Having more than one OTV edge device on each site for high availability. So you are no more in need of STP because the control plane is what taking care of this layer 2 extension, LAN extension. So no need of STP. The following section detail the OTV technology and introduce alternative design options for deploying OTV within and between data center. Now, what is this picture teaching you? You have a OTV interface. See in the left, overlay interface. This is a virtual interface. Like we used to create interface tunnel, you remember? This is interface OTV, overlay, OTV. That is one of the terms that you should know. Overlay interface. What do you see next? Join interface. What is join interface? The interface using which the tunnel is negotiated to the remote site. This is right hand site, or it may be the same site, two device. Yeah, this picture is actually not having any remote site. This is only one site. This is multi-home. This is only one site. Let's say site number 10. Site ID 111. It's only one site, two device. Now this interface have got public IP address. This interface, primary and secondary, negotiates to another site here. It's a WAN interface. So using this interface, this overlay negotiates tunnel. Overlay interface cannot talk to the internet. Overlay interface is a virtual interface. Overlay interface has got this encapsulation capability. Overlay interface will take the VLAN traffic. The VLAN 10, VLAN 20, VLAN 30. So all the VLAN traffics of this office is taken and encapsulated by this overlay interface and kept inside this physical interface. That physical interface is what we call it as join interface. Join interface. The internal interfaces are connecting the local computers in VLAN 10, VLAN 20. You may also have a VPC. You may also have some local devices here. The traffic comes here and then get tunneled out. So the join interface is a WAN interface. Internal interface is the LAN interface of your network. This is the WAN interface. This is the LAN interface. So you may have a normal port channel or you may have a VPC. The traffics are not going like this. No. The traffics are going, if there's a computer here, the traffic comes like this, gets encapsulated with OTV and goes out. So LAN interfaces are called as internal interfaces. WAN interfaces are called as join interface. What is edge device? The edge device is the one which can take the LAN traffic, VLAN traffic, encapsulate it with layer 3 header using the IP address on the join interface as a source and destination IP address as the MAC address, destination IP address as the multicast address. We'll talk about the multicast address a bit later. But the destination is going to be multicast address. Source address will be your join interface IP address. You see? The edge device platform OTV function. It receives the layer 2 traffic from all the VLANs that need to be extended to the remote location and dynamically encapsulates the Ethernet frame into the IP packet and then sent across the transport infrastructure. It is expected that at least 2 OTV edge devices are deployed at each data center. That's called multi-homing. For what? For high availability, for improved resilience. Finally, the OTV edge device can be positioned in different part of the data center. The choice depends on the site network topology. Okay, you saw the figure already. There are 2 OTV edge devices in the site. These 2 edge devices, sometimes it may be directly connected to the cloud, sometimes it may be connected through this 9000 series. That depends on your design of your network. See, in this picture, your edge device is not directly connecting to the cloud. It is connecting via NEXUS 9.3. But let me show you another. In this picture, you can see both the edge device in the site is connecting to the cloud directly. There is no other switch in the intermediate. All VLAN traffics are taken from local interface, internal interface, and it is encapsulated by the overlay interface and kept inside the join interface and sent over the transport infrastructure. Even in this picture, you don't have any edge device except OTV device. OTV device is directly connected to the cloud. That's what we know that paragraph says. It says it depends on your design topology. OTV edge device can be positioned in different part of the data center. The choice depends on your site network topology. In the above figure, the edge device is in the aggregation layer, not in the edge, not in the core. Next, we just saw what is edge device. Now, what is internal interface? Internal interface is just okay. We have three layers, no? Network, access layer, distribution layer is what called as aggregation layer, and then core layer. You remember? You see, this is aggregation layer, and below is what? Access layer. The internal interface is connecting to which layer? Access layer. Access layer is connected to distribution or aggregation layer. Aggregation layer, distribution layer, both are same. And that distribution layer is connecting to the core. Core is connecting to the cloud. What is internal interface? It's a layer 2 interface. It can be a trunk port or it can be an access port. In NEXUS 7000 series, please focus. NEXUS 7000 series, where is OTV? Not in NEXUS 5000, 7000. So 7000 is a very big switch. In that, you have various line cards. Not all line cards are of same type. Some may be M, some may be F. M has got many versions, M1, M2, M3. Likewise, F also have got F1, F2, F2E, F3, etc. Those line cards, they have a lot of variations. M is mostly used wherever you want layer 3. More of layer 3. You can have some layer 2, but more of layer 3. If you need, then M. More of layer 2, then you need F. F series line card, M series line card. For look and all, both will look same only. But inside the architecture, the software, everything is different. Doesn't matter whether it is F or M. If it is bringing a layer 2 traffic, then it is an internal interface. Internal interface is a regular layer 2 interface. This can be an axis or trunk. If you want to allow multiple VLANs across the overlay, then it is trunk. Now, there is no need for OTV configuration on the internal interface. Why? Internal interface is nothing but a regular layer 2 interface. It is simply a regular layer 2 interface. You no need what? Any OTV configuration there. This is just bringing access layer traffic. inside the OTV device. It is just doing what? Local switching, spanning tree operation, data plane operation, flooding, etc. They are basically doing internal interface job. Simple layer 2 job. Right? So this is the link between the edge device or OTV edge device and downstream. What is join interface? As I said, join interface is the WAN facing interface. Join interface is the layer 3 interface. This OTV encapsulated traffics are placed on the physical LAN 3 upstream interface. I told you M series is for routing. So usually the join interface is an interface from the M series. Even F3 series supports routing. So it can also be from F3 series line card. If you are worried about MEF, don't worry. I'm repeating again. M will have more support for routing with some switching. F will have more support for switching and some routing. So that some routing is enough in F3, some routing is there. That is enough to become a join interface. Join interface is a layer 3 entity, and with the current NEXUS OS release can only define a physical interface or sub interface, or also logical one, or as a logical one, layer 3 port channel sub interface. So join interface should be a physical interface. That's all here. It means don't get confused too much. The join interface should be a layer 3 physical or sub interface. Or it can also be a bundle, port channel or port channel sub interface. Single join interface can be defined to associate with a given overlay. Multiple overlay can share the same join interface. You see this picture here? You have a OTV interface. You have a join interface, physical interface. You may have multiple overlay interface 1, overlay interface 2, overlay interface 3. Now all this can use the same join interface. All these three can use the same join interface. All right, that's what mentioned here. Yeah, single join interface can be used by multiple overlay interface. Join interface is used by edge device for different purpose. One, join the overlay. Not only that, to discover the remote OTV edge. Next, to form OTV adjacency with the remote OTV edge device and to form VPN. You need this join interface. Thirdly, you send and receive the MAC address of one site to another site via this join interface tunnel. The tunnel is created using this join interface. Both unicast and multicast traffics are also sent via not only MAC address information you send, you also receive packets, send packets. It can be a unicast packet, it can be a multicast packet over this join interface. Overlay interface is the logical interface. I told you it's not physical. This is the interface which is taking the layer 2 packet and then encapsulating it so that it can be placed inside the join interface, which we just finished seeing, so that it can go through the tunnel to the remote site. Without overlay interface, packet cannot be encapsulated. If it is not encapsulated, then it cannot be kept inside the join interface. Then it cannot be an overlay. So you need this virtual interface for sure. You need this logical interface. Overlay interface is a logical multi-axis, meaning you can have many sites from one logical interface. Multi-axis and multicast capability interface means IGMP, repeating again. Don't underestimate any word in this page. See, it is saying very clearly multicast capable interface, meaning that interface supports IGMP, Internet Group Management Protocol, which is used for multicasting. See, OTV needs multicasting to discover remote site. OTV needs multicasting to discover remote site. Not only that, when a MAC address need to be advertised, it will be advertised to the multicast address so that it will go to all remote sites. Multicasting is good than unicast. If you are sending update to multiple sites, using multicast is good than unicast. So the overlay interface is logical multi-axis and multi-capable interface that must be explicitly defined by the user. We need to create this. Each time the OTV edge device receives the layer 2 frame, which is for the remote site, the frame will logically forward the layer 2 frame will be logically forwarded to this OTV interface, overlay interface. This OTV platform now can encapsulate that layer 2 packet and send it to the join interface so that it can be transported over the routing domain. Now, so far we have seen of course it is on the software and it is on the overlay interface. So overlay interface we saw, join interface we have seen, internal interface we have seen, edge device we have seen. We have learned these terminologies to understand OTV. Now about the control plane. I told you control plane is a layer 3 protocol. Control plane consideration. Control plane consideration. See, data plane is subjected to loop. Whenever we have redundant path in data plane, loop will be there, so spanning tree protocol is must. But here we are not using the data plane, we are using control plane. Control plane protocol. Using this control plane protocol, we form adjacency. We form OTV neighbors. Those 3 sites that you saw in Sri Lanka, in Dallas, and in Perth, they form adjacency by sending hello packets, and they form adjacency, and then they bring up the OTV tunnel. So this OTV edge device, they become adjacency, they form adjacency using the IP reachability that is provided by the service provider On top of this, they negotiate the tunnel inside which the layer 2 MAC addresses will get advertised. Now, to establish tunnel between these three sides should have same multicast address as a group address. So multicasting helps to group these three sites because they have same username and password. Sorry, not username. Because they have same password and same multicast address. Even though OTV is run by many customers, only their remote office forms a group. It is because of the password and the multicast address. Only those three sites in Perth, in Sri Lanka, and in Dallas forms neighbor. Why the OTV in India is not forming neighbor? Because the OTV in India is different customer, different multicast address, different password. So multicast need to be supported in the internet. Usually all service provider supports it. The transport network, they support multicast. If multicast is not supported in older versions, there is an alternate way. Sorry, from this version onwards, this is quite old only. From here only it is started. They started supporting. You can have an adjacency server. In that server, you will mention IP address of the remote site, the public IP address of the remote site, so that every OTV edge device will use this adjacency server and know the location IP address to which they need to negotiate. That negotiation brings the OTV up. This is only if multicast is not supported. But don't worry, all the service providers, they do support multicast. All right, so multicast enable the transport infrastructure. You see, what is important for multicast? One is PIM, protocol independent multicast. That ISP will do, you don't need to worry. The other one is IGMP and the multicast address. And then you need to enable any source multicasting. What is any source multicasting? You see, if you have multiple OTV sites, let me get the picture for you. You see, we have three sites. Sometimes west is sending, east and south is receiving. So who is the source now? West. Which are the groups receiving? East and south. And then east is sending update, west and south is receiving, which means east is the source, group members are west and south. So east is S, south and west is G, S comma G. Multicast works like this, S comma G. Earlier west was S and east was a G, but now east is S, west and south is G. And sometimes south wants to send, so south becomes source S, west and east becomes group member G. So anyone can be a source, no? That is why you need to enable any source multicast. That is one of the multicast type, any source. See, there is also source specific multicasting. This is any cast multicast, any source multicasting. Okay, so this is the important stuff. If the transport is owned by the service provider, enterprises will have to negotiate the use of this ASM group with the service provider. The following figure shows. Now, that's about the multicasting part. Any source multicasting need to be negotiated. Next. How OTV works. You see, multicast enabled transport infrastructure, how it negotiates and forms adjacency. See, that's what we saw in the previous paragraph. They should form adjacent. They should become adjacent. Those steps is what explained here. Step 1, each edge device send an IGMP report. If you know multicasting, you know what it means. That's a join message. Each edge device says, hey, I want to be a member of this multicast and I want to be a source. And I also want to be a group member. So that is why we call any source multicast. They can be a source and they can be a group member. That's the first step. Let me take the picture. Yep. So here you see number 1. Where is number 1 in the picture? You see this guy, the south. The south and the east and the west. Those 3 are sending number 1. Meaning they join the IGMP group. They 3 say, I'm the member of this particular group. Let's say 239.1.1.1. Or it can be like 0 also. The 3 will say the same thing. I am the member of this group. Along with the password, same password. Each OTV edge device will send an IGMP report to join a specific SM group using the carrier control protocol called IGMP group. The edge device joins the group as the host by using the join interface. What is there in the join interface? A public IP address. Using the public IP address, it joins the group. It says, this is my IP address. I belong to this 239.1.1.1 multicast group. So you no need to enable PIM on the interface. The service provider is already a multicast supporting, so no need to worry. You just enable OTV, that's all. All the other things will be taken care. See, you don't need to enable PIM. The only requirement is that specify the multicast address. Specify the ASM group 239.1.1.1 to be used. Second step. The OTV control protocol. What is the control protocol? ISIS. So far they have not mentioned in this document. It is coming later. The OTV control protocol running on the left OTV edge device generates a hello packet. And it sends to all other edge device. See, in this first step, they formed adjacency. They formed one group. They all joined one group. Now in the second step, each edge device will send a hello that will reach the other member of the group. All right. This is the important thing for forming adjacency. First they form adjacency group. Now they are sending hello packet to form adjacency. Now the hello messages are sent across the logical overlay remote through the logical overlay to reach all the remote device, which means they use multicast. For this to happen, the original frame must be OTV encapsulated. An external IP address should be added on top of. See, the source IP address will be your join interface. I already told you. But the destination is the multicast address that you mentioned. This results forming an adjacency. Step 4. Okay, you see, step 1, step 2 is hello. And then step 3, now this guy starts encapsulating all the layer 2 packets. Sorry, encapsulates the negotiation packet and sends to the remote to form adjacency. Step 4, the multicast frames are carried across the transport and optimally replicates to reach all the OTV edge device, and then joins the multicast group. So that's how they form adjacency. This is the step where they form a multicast group. And then the decapsulation happens for the encapsulated packet on step 5. And the hello packets are passed through the control plane protocol process, and then they form adjacency. That's all, This is basically for how they come to know each other. And now the LAN segments are all connected through this tunnel. So 2 important considerations for OTV control plane protocol is a protocol that is running on the overlay is different from the protocol that is running on the underlay. Underlay, you may have any protocol, BGP, whatever. That is no way related to the overlay. So what is used in overlay is ISIS. So OTV control plane transparently enabled in the background after you create overlay interface. This does not require any explicit configuration. You don't need to explicitly configure ISIS. That's what they say here. You don't need to configure ISIS. You just enable OTV. ISIS will be automatically enabled at the background. You can tune timer if you want, but which is not required. Okay. So you are going to use, OTV you enable, ISIS gets enabled automatically. You don't need to know even a single command in ISIS to configure OTV. You just enable OTV. OTV will start encapsulating the MAC address in type length value, which is one of the packet type in ISIS. There are many TLV types. Fine. You can also enable security to form OTV adjacency only with your branch office. You enable authentication so that unauthorized routing messages will not be injected. Right? Now, once the tunnel is formed, you see the MAC table get distributed. You see, this west locally have got VLAN 100 with 3 MAC address. That is encapsulated and sent as a OTV update through the tunnel. And now listen carefully. On east, it says the same ABC MAC address, VLAN 100, but it also knows the site address. What is site address? IPA, which is west IP address. So in order to go to this MAC A, traffic should go where? West address, IPA. You see IPA here written here and here. Do you follow? Did you understand this? You see, there are 3 computers connected in site west. Site West has got 3 computers and their MAC addresses are A, B and C. And it belonged to VLAN 100, locally connected. As soon as this MAC address is learned, the OTV will send it as an update over the tunnel. So it goes to south and east. In that edge device, it is learned in the MAC table like this. If you want to go to MAC A, which is of VLAN 100, you should go to IPA. If you go there, you will find this guy here. You understand now? See the difference in the table. The locally learned MAC address will not have this field, is not there here because they are locally learned. 3 new MAC addresses are learned. Whereas the remote sites will know the address to which the packet need to be delivered if the MAC address matches with A or B or C in VLAN 100. Yeah, OTV join interface, the public IP address. Right. Next. That's what explained here. You can go through this later. Now, the MAC table that is learned will remain there only for 30 minutes. If in 30 minutes no communication happens, it will remove. So, for example, this is down. This computer is B is down. From here, it will be removed immediately. But from here and here, it gets removed after 30 minutes. Because there won't be any communication, it gets removed 30 minutes. After that, see? Same control plane communicates. Okay, for example, if a specific network entity is disconnected from the network or stop communicating, the corresponding MAC address would be eventually removed from the CAM table of the OTV edge device. This occurs by default every 30 minutes on the OTV edge device. The removal of MAC address entry triggers the OTV protocol to update all. See, usually it triggers and immediately removes. In case it didn't get removed, it gets removed after 30 minutes. There is a trigger entry also. So you can extend VLANs from one LAN to another LAN. For example, you can extend VLAN over OTV network in order to allow VLANs with the same VLAN ID, which you saw in the picture. What is the VLAN ID in site West? 100. You are using the same VLAN ID, which means same VLAN is extended. What if you want these 3 computers to talk to VLAN 200 in south? Is that possible? Yes, it is possible. You can map. You see? You can extend VLANs over OTV in order to allow VLANs with same VLAN ID seamlessly. For example, VLAN 1 of site A extended to site B VLAN 1, blah, blah, seamlessly. But from this release onwards, M-Series line card can map VLAN of local site VLAN with a different VLAN ID on the remote site. That's what I said. 100 can be mapped to 200. See here, for example, when VLAN One on site A, you can map it to VLAN 2 on site B. You understood? That is on M series. In F3 series, it is not supported. All right? You can have trunk port for that. What is traffic depolarization? You see, for redundant, yes, 4096. Traffic depolarization. What it is, you see, right now you have only one edge device. What if that one edge device goes down? You cannot reach. So what do you do? Multi-homing, isn't it? We learned that. You use multi-homing. So you are going to have one more. So what you can do is you can use secondary IP address. You see, you can use secondary IP address so that if one goes down, the secondary IP address will be there to take care, right? You see, when you have two devices as edge device on each join interface, you will have one primary address and another secondary IP address. Then two edge device totally will have 4 addresses. You understand that point? Two edge device, Girish. Then how many join interface? Girish, please answer. Two join interface. In each interface, you can have one primary address, one address secondary. So totally how many address? Girish? 4 different IP header values are supported now. So if one primary address fails, don't worry, there is a secondary address for the same. So traffic depolarization is supported. Yeah, that's called traffic depolarization. Okay, so but you need to mention this secondary keyword on the join interface. That is important. All right. So the route depolarization, OTV gleans in local source IP address from the local interface. The remote IP address will be the ISI through the remote. Fine. ISIS provides the remote reachability, all the stuff. See, multiple unicast tunnels, because you have 4 IP address, multiple unicast tunnels are used for output. So route depolarization is in. Another thing is, for route depolarization, you need the multicast core support, right? So this feature will enable load balancing based on the source and destination MAC address. Hope you understand all this thing. Let's move on to. It is enabled by default, so don't worry about it. Encapsulation format. Listen carefully. Earlier, there was GRE used for encapsulation, but now it is UDP. Same like VXLAN. Now it is UDP based. UDP port number 8472. Fast convergence. You see, there, even though you have 2 edge device, there will be one edge device automatically elected based on pre-elected based on their IP address, and it is called as authoritative edge device. What is the role? If one MAC address is learned, this will give to the other edge device also, so that they will be synchronized. And this authoritative edge device only will decide Which edge device will forward the traffic for what MAC address? So even though you have two devices, one will be the authoritative edge device. See, authoritative edge device first ensures that it has disabled traffic forwarding for all VLANs. First, it will ensure it has disabled all forwarding, and then if the authoritative edge device is still an overlay and site reachability, AED indicates the failure. Or, okay, this is talking about the failover. See, authoritative edge device will say, I will forward the traffic for these MAC addresses. You forward the traffic for the other MAC addresses when you have more than one edge device. And now, when there is a local failure, it may not forward the packet because there is a local failure. So AED ensures that for all VLAN the traffic is disabled, and then it will check whether the tunnel is there, whether the remote site is reachable. AED indicates this failure by bringing down the AED capability on either adjacency. So it brings down the authoritative edge device down, means I'm no more an authoritative edge device because I have some local failure. So that the other device will take over, the other edge device. See, if the AE device does not have reachability or it is shut down, the other edge device detects this failure and uses dual adjacency timeout. In both cases, the pre-elected backup AED immediately becomes an authoritative and it starts forwarding traffic for all VLANs. These things are automatic. We are just seeing how it works. So this is when you have dual adjacency, what I just said. Site edge device, when an edge device loses the tunnel adjacency, first edge device immediately triggers the hello message with the list updated to exclude that edge device. Basically, what I explained is what written. For fast convergence, you can also enable BFD. Now, if a VLAN fails, if AED loses the forwarding readiness for a VLAN, it generates the VLAN status and disables in both the AED. So that the traffic will not be forwarded. Simple, you can go through this, and this is the URL. You are going to do lab. You see, these are all things we have finished. Now, when you say lab module 1, it will just show you the commands. This is the topology that you need to build in your EVE. You just see the commands only. This is the command to enable OTV feature. Do it on both the edge device. And these are the VLANs that you are going to extend. Create those VLANs. And then, according to that topology above, you need VPC. Even without VPC also you can configure. All right, without VPC also you can configure. And then you want to allow these VLANs now, so you say trunk. So traffics are received through the port channel for all those VLANs from here, and then sent through the OTV to the remote site. All right, and then you remember I told you need to enable IGMP so that any source multicasting can be enabled. And then put this command OTV encapsulate format in UDP. By default, it is GRE. I told you you can use UDP. All right, and then you can give a site number, site identifier 11111 and then this is the overlay interface, virtual interface that you're going to create. And then you need to join, you need to tell which join interface to use. In this case, it's a port channel. You see this picture? The join interface is a port channel 100. And then for the control plane, you need to provide a multicast address. For a data plane, you need to provide the subnet of the multicast, same multicast, or different multicast is here, they're using different. And these are the VLANs that you need to you are planning to mention. That's all. Right, that is the OTV configuration. Now for fast convergence, go to next module. For fast convergence, enable BFD. Yeah, this is the interface that is downstream over the LAN. Enable. This is for fast convergence, BFD. And then broadcast group. In case if there is a need for a broadcast to be sent, you can optionally give this multicast address so that actually no broadcast is supported. So you can use this multicast address to send the broadcast to only to the group members. At last, verify. Show OTV, ISIS adjacency. You can see the remote sites forming adjacency. And you will also see the MAC address that are learned via those. This is the command to see the MAC address. Show OTV site, it shows there's a remote site with this system ID. Now, this is not the command for MAC address. This is the command for MAC address. Show OTV VLAN, it shows that VLAN 11 coming from this site. Star means it is, I think it is local. See, AED. Authoritative edge device, local, this local. And these are coming through tunnel coming from other route, other device. The local IP address, neighbor IP address, adjacent devices. Testing. That's it. Here it shows only the commands and verification commands, configuration commands. This is all you need for OTV. You may use this as a reference when you are doing in production or when you are doing this in the lab environment. You may use this.